So good evening, everyone. Happy to see you here today. I am Leonid Khedyk, CTO at PLVision, and I'm going to take the next 30 minutes to tell you about Stratum advances in the direction of optical networks. First of all, first few words about the company and why we are here. So the company primary focus is embedded software and networking software development services. So for the last 12 years, we are doing development in the area of network operating system, integrating, porting, extending different both open sources and proprietary network operating systems and moving it to different platforms for the major silicon vendors, as you can see. So this is probably the major reason why we decided to join ONF more than a year ago, once Stratum project was seeded, and it was a big interest for us, and I think it is a big opportunity for the company. Moving further to optics. So I stolen this slide from ODTN track. If you wish to learn more about ODTN advances and optical networks and the work ONF doing in this area, you should probably visit tomorrow's evening sessions on this topic. Now I just give you a brief introduction of what it is all about. So the idea is to take optical network, separate it in different component and pieces, put open software and open and common interfaces to control it. From my point of view, it looks like ONF is pushing the SDN principles proven in the data center environment out to the optical wide area networks. So there is some motivation on the slide about why it's all started from the age of the optical network, and in particular from transponders that bridging packet and optics worlds. So where is the Stratum in this picture? So quite the same software architecture. We have orchestrator or business software above. We have ONF controller with ODTN application inside. And below it, we have different kind of hardware. So probably it's not quite good to see, but Stratum is going to land on those boxes on transponders in the bottom of the slide. One of the ODTN cases is ONF controller. OLS controller, there is a multiple elements of optical network in between transponders, and there is another piece of software that enables control of it. So as far as I know, ODTN currently using TA API to deal with this portion. So
is it like a hardware component between, or is it software layer?
It's a software layer that controls elements on the way between two nodes.
Just to add a note on that, Ali, basically that piece is the one that controls everything between the two transponders and abstracts it to ONF as basically as a big switch. We have done demonstrations with ADVA controlling WSS amplifier, maxponders underneath that, but not exposing them to ONF directly, but instead managing them to that OLS controller, which is a software piece. Thanks.
Thank you, Andrea. He is the one who made us looking in this direction. So one of the ODTN use cases is direct connection between two data centers. So on the left and right side, you have live leaf-spine topologies. And in order to connect it, you attach a transponder to a leaf switch and put optical link in between it. So you add another device. You need to teach controller to control this device. Otherwise, it would be kind of black box link, and nobody knows without human intervention what is going on inside it. So it would be much more easier and convenient to have such kind of picture when leaf switch is merged with a transponder, so it is capable in one box to do both packet and optical sides. So we are lucky enough to live in 2018. Early this year, each core introduced this Cassini platform, which is white box switch. It is open design contributed to OCP. It has Broadcom Tomahawk Plus chip running on it. And what is most important, it has pluggable slots to insert optical transceivers in it. So we are pretty covered on the hardware side, but what about software? The obvious choice is, of course, Stratum. So on top of it, we have regular Stratum interfaces. It is before on time, it is GNMI, GNMI, everything running on gRPC. Below Stratum, we have some kind of SDK to control data path. And another important piece of this puzzle is TAI, or Transponder Abstraction Interface, which is another open initiative. It is driven by Telecom Infra project. The key idea is to create a common denominator interface for different types of transponders. So you can control via the same set of functions different vendors. It's quite similar by the idea and approach taken to SAI interface, switch abstraction interface used in Sonic software. So let's take a closer look at the details of on those interfaces. Starting from the top layer, we have GNMI. Luckily, OpenConfig already defines the data models and abstractions for optical devices and optical path control. If you open, for instance, one of the definitions, you might be scared about amount of attributes and options you will have. So naturally, we limited our implementation to just a few. To name them, it is, first of all, it is operational mode of the port, then frequency, output power, and of course, we need to read the status from the link. It is input power, some counters, things like that. Moving further to glue layer, which is central for this project, it is Stratum. So I think everyone have seen this diagram a number of times today. I just highlighted the major pieces we've touched to provide control over optics in Stratum. So first of all, it is GNMI, new path for optical interfaces were introduced. Then we've got to extend switch interface. Right now, it only provides control over regular Ethernet interfaces. So new types of ports got to be introduced. And in fact, they mimic OpenConfig definitions. Behind the switch interface, there is a number of classes which were discussed in details earlier today. We've got to store configuration attributes, operational and runtime data. Then comes node and chassis manager, their responsibility to initialize TIE library, probably perform plug and play in the future. And finally, we have the TIE API layer below. Everything we got on GNMI side is translated to TIE API and vice versa. Once we've got some notification from the transponder, we push it back to the controller via gRPC interfaces. Moving ahead, that's kind of picture we are going to have in the nearest future. So instead of having two separate boxes to establish connectivity between two leaf and spine topologies, we can use just one single box controlled under a stratum. Right now, we have draft implementation of this. Some pieces, some portions of it is still hard-coded. But I think it's just a question of time to bring the whole functionality and enable more flexible optical network for ONOS and Stratum. In summary, disaggregation and separation are very kind of popular words nowadays. Still, I think it's very important to keep interfaces, first of all, shared and clean. So, meaning we have to not overload certain layers with functions that are not belong to them. Putting this combination of interfaces together, OpenConfig, gRPC, TIE, and Stratum in between, I think we have proven it can work this way, and the separation is done in a good manner. So it is open, at the end of the day, it is an open source project, so everyone is welcome to join and contribute. Here are some links just to start with Stratum and ODTN. I probably should have added a GitHub repo now available for everyone. I just was not aware of what it should be. I think that's pretty it. So I'm ready for your questions.
Thank you. Questions?
What kind of P4 runtime stuff are you pushing down into this device? Like, it makes a lot of sense using OpenConfig to manage all of the optical ports, but what kind of stuff are you doing at layer 2? That seemed interesting.
Well, honestly speaking, in the scope of this project, we were not too much concerned about P4 and P4 runtime. So our major goal was to enable new kind of ports working in this system. At the end of the day, you can just put simple switch on it and establish connectivity. But I think for this particular case, it might be more interesting to do some smart filtering. Probably not all the packets, all traffic has to be forwarded in the optical links and back again. We didn't explore this direction yet. I think people who are involved in ODTN program can talk more about it and provide you with a better idea of.
So maybe I can ask one.
Sure.
So in the context of sort of adding a new SDK vertical to Stratum, what were the sort of biggest challenges you guys faced?
The biggest challenge, I think the most challenging was actually switch interface and those generic proto definitions we've got to put in place to make it working. I'm still not sure whether the changes we made would be accepted easier by community. I believe we will have to do several rounds of review. Then initialization and kind of auto detection, which are on our agenda. I think it's kind of still not clear yet what is the best approach to implement that. GNMI part was pretty straightforward. Well, and adding another library to a project like transponder API is not a big deal. So overall, it does not require significant efforts to add something like this to a prototype stage. But if we are about to implement complete open config specification, it might require more time and more people.
Hi, I was just wondering about the performance. So if I'm, for example, interested in telemetry from the optical side, and an event happens, such as, I don't know, a signal goes too low, what is the end-to-end performance? How soon do I get an event saying, hey, the OSNR, the DSP has detected that OSNR is too high, for example, too low, sorry. Yeah. Roughly, you know, is it 50 milliseconds or is it 50 milliseconds?
Sorry, I don't keep such numbers in my head. I think Ali can elaborate on the performance of gRPC. I believe we've got such kind of slides a year or two ago.
First of all, it depends what kind of platforms you're running it on, right? So do you have a good enough a CPU that is running Stratum or not? But right now, Stratum is very, very bare metal-like, so it doesn't have too many layers in between. As long as your SDK or whatever, TAI in this case, will give you the signal in almost real time in terms of the milliseconds, going from that SDK signal all the way up is as fast as we can imagine. So if it's, because it's almost immediate. So I don't know if you guys saw the presentation that Yi had on the leaf. You can see each leaf actually has as a functional, has a functor. It doesn't actually update. So as soon as you get something, that functor is going to sense it and it's going to send it back up to you. So you can assume that this is almost immediate or as fast as it can be on the gRPC. And then from the gRPC going all the way back up is like the performance of your network. So you have the network layer, and you have your SDK layer, and you have a very, very almost negligible amount between the SDK and the time that is actually pushed to the network. So you can imagine that that part is sort of negligible, and everything else becomes your network and SDK.
And then lower than the SDK, that's something that is for depending on the tie and the module itself, the optical module itself. So that would be a question for the vendor of the module and the implementation of tie. We could ask Wataru from the tie initiative if he has some measurements. I don't know them by heart, but I think it's going to be compatible with the optical vendors that are in the existing space.
So in this case, it's a question to link between Stratum box and controller. So and it depends on how you build your control network.
I can give you an example. In case of Broadcom, for example, if you just take out one module, it just takes, for the SerDes part, it takes a couple of sometimes seconds for you to sense it. So I'm not saying that that's going to be something that you see here as well, but it sort of depends on the file layer.
So we've seen down sensing come back pretty quickly, but again, it depends on the SDK. Actually, in our demo booth, we were just kind of curious. So we were doing some testing, and we've seen going from basically transceiver or link down event, like transceiver pull, to path restoration. And this is not optical on packet networks, going through Stratum layers up to ONOS controller, ONOS detects event, and then computes new topology, pushes down, etc. Is around 30 milliseconds. Yeah, with a basically negligible back-end network delay, because we have a single management switch with ONOS connected to it. But so obviously you could add more network delay, but you could also add less network delay if you took the component that has to do path restoration and actually co-located it on the Cassini box. Yeah. So again, it depends upon what you're how long it takes the SDK to realize something's wrong, how long it takes to tell Stratum. But within Stratum, I mean, it's C method calls, and we're talking about a dozen or so C method calls, not context switching, et cetera, et cetera. So yeah, I mean, if you want, Max or Yi maybe can pull a link for you, and you can watch the traffic restoration in the demo. But yeah, like Ali's saying, sometimes for reestablishing links when they're plugged in, depending upon the quality of the cable, the type of DAC you're using, and the SerDes parameters you have, it can take a couple of seconds before a link is reestablished at the PHY layer.
And then obviously, as you know, the optical side could take even more, depending on power, depending on modulation, how much are you, like the light, there's a lot of other things. So I don't think we have done any testing in performance. This is an early stage implementation, so thanks a lot to Leonid and his team to having done this. There's going to be an iteration on the review and stuff like that, but at some point we will publish some measurements.
That's a good roadmap item, which is measurements in general of the system. Okay, let's thank Leonid.
Thank you.